Welcome back. So, we don't know the antiderivative of natural log of x, but maybe we can find it by using parts. We can't make dv equal to natural log of x because we don't know the antiderivative, but we can certainly make u equal to the natural log of x, which means that dv is just dx. The derivative of u is 1 over x dx, and v is equal to x. So the antiderivative of natural log is u times x, u times v, that's x times natural log of x minus the integral of v du, but that's x times 1 over x dx, which is just the integral of dx, which is just x, which means that the integral of the natural log of x dx is x natural log of x minus x plus a constant. Now you know. If I were keeping track of interesting integrals, antiderivatives, etc., I might add that to my list. Hey, let's do another one. What about the What about the antiderivative of arc sine of x? I have no idea. But I do know the derivative of arc sine of x, so I will make u equal to arc sine of x. The derivative of arc sine of x, of course, is 1 over the square root of 1 minus x squared dx. And no, I don't have that memorized. I looked it up. And v is equal to x, which means that the antiderivative of inverse sine using parts becomes u times v, x times the inverse sine of x, minus the integral of v du, x over the square root of 1 minus x squared dx. And this looks to me like a substitution problem. I'm going to let u equal 1 minus x squared, which means that du is equal to negative 2x dx. And I'm going to go ahead and highlight my du. At least if I put a negative 2 in front of it, which means that I need to put a negative 1/2 in front of that to compensate, which means that I'm now looking at x inverse sine of x plus 1/2 the integral of negative 2x dx over square root of 1 minus x squared. And just powering on, we get x inverse sine of x. Yes, advanced math takes a lot of writing. Plus 1/2 the integral of 1 over the square root of u du. And unfortunately, because I'm working on teeny little pages, I now have to turn to the next page. So I'm just going to write out the whole thing that we have so far. The integral of arc sine of x dx is equal to x times arc sine of x plus 1/2 the integral of u to the negative 1/2 du. And of course, the integral of u to the negative 1/2 du, copying this whole line out again, is 2u to the positive 1/2 plus a constant, because now we don't have an integral left, which means that we can conclude that the integral of arc sine of x dx is x times the arc sine of x plus, now let's not forget that that is 1 minus x squared to the 1/2 plus a constant. Now we know. Look at that. Two functions that we didn't know the antiderivative of before, and we were able to use parts in order to find it. Why don't you, just as an exercise, go ahead and use parts to find the antiderivative of tangent of x dx. So you can pause the video. And now that you are back, we discovered that the antiderivative of tangent inverse or arctangent of x is x arctangent of x minus 1/2 times the natural log of 1 plus x squared plus a constant. Now you know. And, oops, if you were wondering, you could do that one as well.